So today let us discuss this activity 2.3.8, where it is given that how can we obtain pure copper sulfate from an impure sample. Now suppose we have a sample of copper sulfate. Okay, so activity, the first step, it is written that take some impure sample of copper sulfate in a china dish. Alright, so we have taken some impure salt. Impure means some contaminating, some object will be mixed with that. Alright, now dissolve it in minimum amount of water. Okay, we have dissolved it. Then filter the impurities out. That means we know that when copper sulfate is dissolved in water, we will get a solution, a true solution. And if you filter the true solution in the filter paper, we generally don't get any residue, but here the copper is mixed with some impurities. So when you dissolve it in water, the impurities will be mixed with water only. So when you filter, the impurities will gather at the filter paper as residue. So that means we have removed the impurity. Now in the after removal of the impurity, what we have now? Now we have copper sulfate solution, but we don't need the copper sulfate solution, but we need pure copper sulfate only. So somehow we have to remove the water part now. Okay, now see here, point number 4 is given: evaporate water from the copper sulfate solution so as to get a saturated solution. Okay, so now we are evaporating it. Evaporating means, suppose we are applying some temperature. We have kept the china dish on a tripod stand, and below that we are using some burner. Alright, now we are evaporating. So water molecules present in the solution will be evaporated. Alright, now what we will do is, we will not evaporate the solution till the last moment. Till the last moment means when to stop, that one how we will understand. We have to stop it in such a position where still some water remain present. If we don't do so, then there is a possibility that it may undergo, or there may be charred. Charred means it may burn. The salt which is present there, it may become black or it may get charred. So that is why what we do is, we avoid the complete evaporation process. That means we evaporate, but still we keep some water there, so that it does not undergo any burning, or char does not take place. Okay, so that is why we keep it in this way. And then that copper sulfate along with some water is kept undisturbed for at least for 1 day. See, in point number 5 it is written, cover the solution with filter paper and leave it undisturbed at room temperature to cool slowly for a day. Okay, so when you are keeping it, the evaporation will take place by itself. That means we are not supplying any more heat. Evaporation will take place, but it will take place by itself at room temperature. So it is evaporation will take place. Alright, and after 1 day, when you observe, you will see that that copper sulfate, it has turned to some crystals of copper sulfate, and this process is called crystallization. So impurity is removed, as well as the copper sulfate, it has come in the form of crystal. Alright, so this whole process is called crystallization, and in this way we can remove the impurities present in a copper sulfate sample. Now 2 points are here, and you can see this one: simple evaporation. Okay, this line you see, crystallization technique is better than simple evaporation technique, because first point, some solids decompose, or some like sugar may get charred. Just now I told you that it may get burned, okay, on heating to dryness. So that is why we don't make the solution or we don't heat the solution till dryness. We keep some water, and then along with water we keep it for 1 day. Alright, next point is that some impurities may still remain there, may still remain dissolved in the solution even after filtration. So these 2 points you have to write if you are asked that why do we use crystallization technique and not direct evaporation technique. Okay, so these 2 points you have to write. Then 2 applications are there. That means where do we use this crystallization process? So that is, the first one is purification of salt that we get from seawater, and next one is separation of crystals of alum. Alum means it is fitkari, okay, from impure sample. So these two applications are there, that is, these are the applications of crystallization. Then the next topic which is there is water purification system. You can see here that there is a figure which is figure 2.13, how we can purify water. Okay, simple one. See here, some setups are given. At the very beginning it is a reservoir. From the reservoir means some impure water will be present there, and the water that we get from water supply, so that water is what? It is a pure water. Okay, and how this water is purified? So for that, you see that in the reservoir, first of all, some water with impurity is kept. Okay, from there, from mud and some sands, these things will be mixed with this water, and this water through one pipe it comes to the sedimentation tank. You can see here, sedimentation tank. So in this sedimentation tank, what happens is, water is allowed to get settled there, and when it gets settled, some heavy impurities like sand or maybe some stones or some other particles which are heavier, those particles will settle at the bottom, and water will be taken to the next tank from the top. If you see nicely, you see here that the pipes are fitted at the top of the tank, not at the bottom. Okay, so that because at the bottom impurities will settle down, and water will be taken to the next tank, which is the loading tank, using a pipe, and the pipe is set at the top of the tank. Okay, then in loading tank, what is done? The heavier impurities are already settled down. Now the lighter impurities, how to make them settle? So for that, in loading tank, when the lighter impurities are suspended, they are floating, the lighter impurities. So some object or some compounds called potash alum, this potash alum is used in this tank. This potash alum reacts with water, okay, and it make it makes the suspended impurities to settle down at the bottom, because suspended impurity, if you don't treat it with any other object, it will remain suspended, it will keep on floating, but we want to keep them settle at the bottom, or make them settle at the bottom. So how we can do that? By using some compound, the name is potash alum. Okay, then next tank, that is the filtration tank, and you can see that in the filtration tank we have fine sand, gravels, coarse gravel. Okay, so that water can pass through it. So that means the impurities present in water will be obstructed by these gravels, sand, because the you can say that the gap or the gapping between two sand particle or two gravel is very less, only water can pass through it, but impurities cannot pass through it, impurities will be filtered. Okay, so that is why it is filled with gravels, then coarse gravel, then fine sand, in such a way that water should pass through them, and when it passes through them, the impurities will stuck there, but water will easily flow, and it will be collected to the next tank, which is in this next tank. What is done? That is chlorination is done. Chlorination means, till now, till filtration tank, we have purified the impurities present, but we have not used anything to kill the germs present or to kill the bacteria present. So that is why in the next tank, that means in chlorination tank, chlorine is used. What is the purpose of this chlorine? It kills the bacteria or germs present, and finally the water becomes suitable to drink, and that is why now from this chlorination tank it will be supplied for household uses. Okay, so this is how we purify water. Then some questions are there. First one, how will you separate a mixture containing kerosene and petrol different in their boiling points is more than 25 degrees Celsius, which are miscible with each other? So for miscible, if two miscible liquids are there, which process do we use? Generally we use distillation, sometimes we use fractional distillation. So here, since the boiling point difference is more than 25 degrees Celsius, we can go for only normal distillation process. Fractional distillation, when do we use? When the boiling point difference is less than 25 degrees Celsius or 25 Kelvin. Okay. Next one, name the technique to separate butter from curd. What process is that? It is centrifugation. Then next one is salt from seawater. Salt from seawater will be, it may be evaporation or crystallization. In crystallization you can write both also. Then next one is camphor from solid. So camphor from solid, it is the first process. First process means this one. Camphor from solid means one is volatile, this process. Okay, just a second, not this one, this one. How we can separate a mixture of salt and ammonium chloride? Okay, so salt and ammonium chloride, by what process? By the process of sublimation, because here out of salt and ammonium chloride was more volatile. That means when you heat it, ammonium chloride becomes gas. Similarly here, what we have? We have camphor and this one. No? What we have is camphor and salt. So camphor is a volatile one. When you use temperature, it gets converted to vapor, but the salt will remain in the dish. Okay, so that is what process? Sublimation process. Then next one, what type of mixtures are separated by the technique of crystallization? By the technique of crystallization, what type of mixtures are separated by the process of crystallization? Okay, for this one, question number, just a second. For question number 3, you can do one thing. You try to find out this answer of question number 3, and if you cannot, in that case I will discuss this one. Okay, thank you.